Okay, Matthew.
Hey, thank you. Welcome today to Sustainable Change Alliance conversation, opening the tap to water impact investing. I'm Matthew Stotts, a local impact investor and board member of Sustainable Change Alliance Foundation, and a member of the investment committee for Sustainable Change Alliance Incorporated. A brief description of Sustainable Change Alliance. We're an impact-oriented, member-based, not-for-profit educational group. We are focused on impact investing, which we define as bringing financial and other resources to double and triple bottom line organizations that are trying to address big social, environmental, or health-related issues and trying to do that in a sustainable manner. Some of those organizations are for-profit, some are non-profit, and some from the independent sector. So a little bit about the logistics. So you know this meeting is being recorded. You're all on mute except for our guest speakers and myself. The chat room function in Zoom will be how we're taking questions while guests are speaking. And if we have time towards the end, we'll open it to open discussion. I will also remind those of you who signed up for the after hour, we'll have 30 minutes of more social discussion with those folks who can stay behind. So I wanted to give a little context about what we've been doing in this virtual format. We're committed to providing education, community, and inspiration for our members, sponsors, and the broader community of impact investors and folks interested in impact. Our interactive web series, SCA Conversations, have featured community leaders, entrepreneurs, and big thinkers around regional and global impact themes, and gives us a chance to gather with our community during this difficult time where we're separated. SCA has hosted over 20 virtual programs and almost 1,000 attendees around impact themes that included healthcare and COVID-19 response, agriculture and food resiliency, homelessness, energy, environment, business impact during COVID, and general startups and investing around impact. In order to make all that happen, I'd like to acknowledge the hardworking and dedicated SCA board members in the meeting. Thank you for your support and everything you do to make the organization run. Very grateful to you. And finally, we couldn't do any of this without sponsors. Our founding sponsors, Argyle Capital Partners, Impact Family Office, Maps.com, and UBS. Thank you very much. Our platinum sponsor is Nixon Peabody Law Firm. And we have a silver sponsor in Brashears Insurance. If you're not a member of Sustainable Change Alliance Foundation and you want to get involved, join us in this journey in becoming more informed and looking at new opportunities for impact investing, please do so. And if you're interested in sponsoring, we could certainly always use the help. It's my real honor here to introduce our first panelist in this conversation about water and opportunities for impact investing. And I have to say, introducing Dr. Jeff Dozier is a bit of a challenge. When you have a Wikipedia page as long as his, I didn't even go near the academic citations. So it's very hard to think of how to do a proper introduction. So I'm gonna do this. I'm gonna read from the jacket of his recent book, Lakes and Watersheds in the Sierra Nevada of California, Responses to Environmental Change, which was published in December of 2020. Jeff Dozier is Distinguished Professor Emeritus in the Bren School of Environmental Science and Management at University of California, Santa Barbara. He's a fellow of the American Geophysical Union and the American Association for the Advancement of Science, and is a distinguished scientist for the Chinese Academy of Science. Jeff will provide this hour's conversation with the context of California's water situation, should we call it, as we address climate change and the demands of our state's population. I'll turn it over to Jeff now. Thank you.
Okay, thanks, Matt. Let's see, everybody, please don't be intimidated by that title of Distinguished Professor Emeritus. Two of those adjectives just mean old. Some points I wanted to make in this to sort of set off the rest of the discussion. The first is the recognition as to how dynamic the hydrologic cycle is. The water content in the atmosphere is surprisingly small. If you took all the water out of the atmosphere and spread it evenly over the earth, it would be a little bit more than an inch deep. And yet worldwide, precipitation is a little less than 40 inches. So if you make that division, that means the atmospheric water is recycled nearly 40 times a year and about maybe 35 times a year. And so the average amount of time that a water molecule spends in the atmosphere is about 10 days or so. Now, over the ocean, there's more evaporation than there is precipitation. And over the land, there's more precipitation than there is evaporation. And so that excess over the land is what produces the water that runs off into the ocean. The other point to make is that the water cycle is coupled with the energy cycle. And the reason for that is that if you evaporate water in one location into the air, and then that air mass travels somewhere and gives the water up somewhere else, then you've not only moved the water from one place to another, but you've moved the energy. And so about a third of the global circulation energy is in that part of the water cycle. And the other parts of it are then, warm air moving from one place to a colder place, or water in the oceans moving. In terms of the reservoirs of water, 96% of water in the world is in the ocean, and about 3% is in snow and ice. And so what's left is about 1% that we deal with. Now, if we focus on California now, to come down from that global picture, the biggest climate-related issues in California are water and fire. And of course, they're related. So the way water is used in California, there's about, the average amount of water is about 77 million acre feet. About 50% of that goes into environmental flows, about 40% into agriculture, and about 10% into urban use. But those statistics are a little bit misleading. And the reason is a lot of that environmental flow is in the North Coast, where there's lots of rain, not much agriculture. And so it makes a little bit of sense to adjust those numbers to reflect what's on in the rest of the state. So the water that the humans actually use, and that's about 80% of that for agriculture, and about 20% of that is urban. And of that, about 2/3 of the water comes from snowmelt. In the Central Valley, of course, most of that water comes from the Sierra Nevada. In the Owens Valley, where the water from there flows to Los Angeles, that's mostly snowmelt. And much of the Colorado River flow comes from snowmelt in the upper Colorado. The other thing, of course, we know is there's a lot of spatial variability in where there is water, from maybe a precipitation of 5 inches a year to over 100. And so California's water is characterized by a lot of conveyance, moving water from where it's available to where people are using it. The other thing that we have to deal with is the interannual variability. So, the wettest years can be almost 10 times as much precipitation as the driest years. And I know that in conversations with farmers, I kind of ask, well, what can science do to help? And one of the replies I got was to say, well, we want a uniform, reliable water supply. And, my answer is, that's not what nature gives us. The other characteristic of California to recognize is that the reservoir capacity is limited. That if you total up all the reservoirs on the west and east side of the Sierra Nevada, that total amounts to about the mean annual flow. And what that means is we can get through a year of drought, but it's hard for the reservoirs to supply more beyond that. So the way that we have gotten through many of the droughts is through pumping of groundwater. And Helen Dahlke at UC Davis has made an estimate of just how much groundwater has been pumped over the century. And the extra groundwater pumping has equaled about 10 times the reservoir capacity. And what that means is the elevations of the water table are declining, and there's even been land subsidence in the Central Valley as a result of the groundwater pumping. So if we look to the future, there are hypotheses about how climate is going to change the water supply. So one question is, there going to be more or less precipitation in a future climate? And the answer to that is yes. We don't really know. And the climate models are give different results as to whether the annual precipitation will be greater or smaller in this part of the country. But some hypotheses are, I think, more more easily substantiated. One is that some of what now falls as rain falls as snow will instead fall as rain. So there's going to be less snow and it's going to melt earlier. There's also going to be more energy available for evapotranspiration. And then one of the questions that we're trying to grapple with is the interannual variability going to increase? That is, are the drought years going to become more frequent? And there's some reasonable hypotheses about that, but I would say that that the jury is still out. Now, I'm actually a snow hydrologist, so probably a lot of what I work on is the importance of snow. And the snow is really our big reservoir, because the precipitation that falls during winter is stored in the snowpack until the spring, whereas rain that falls in the winter runs off from the mountains. The mountains themselves are pretty important, both in California and globally. If we look at the global scale, about 25% of the land area is in mountains, but probably 50 to 60% of the water comes from the mountains. So the snow is an important reservoir. And if we contrast that with the surface reservoirs, one of the dilemmas we face in managing water is that the surface reservoirs have opposing functions. That is, they exist both for flood control and for water resources, including hydropower. So the problem, if we have rain coming instead of snow, is that rain comes in the season where flood control is an issue. And so the strategy then for flood control is, during the time of year when you expect flooding, the reservoirs are try to be kept pretty empty. Snow is also really important in the mountain ecosystem itself, in providing soil moisture that exists well into the summer. And of course, that really affects the fire hazard. So in terms of technology, what are the kinds of things I'm looking forward to in the future? One is the forecasting of precipitation beyond the week or so that a weather forecast works. So the weather forecasts are actually pretty good, but it's when we extend that out to the precipitation that's likely to occur weeks from now, or the amount of precipitation in a season, that's really an area of research, and that there's some promise of being able to do that. The forecasting of runoff is occasionally problematic, because measurement is also an issue. That is, the measurement of just how much snow is in the mountains can benefit from technology. And and also the being able to measure recharge of groundwater is something I look forward to. Some of this can help, remote sensing can help. For example, the Airborne Snow Observatory, which uses an airplane measurement with LiDAR to measure snow depth, is used in some of the watersheds. And then I think in the future, the importance in California in terms of managing water is going to be the judicious use of groundwater, as mandated by the Sustainable Groundwater Management Act. But that act doesn't actually tell us how to do it. And so the water districts are trying to figure that out. And so how you couple the use of groundwater with recharge and irrigation, I think, is our main task for the future. And I'll stop now. Thanks very much. And I look forward to other people's remarks.
Oh, thank you so much. I think there's something so interesting about the context you provided. It struck me how much we actually roll the dice every year. And also in terms of, being able to make it through a drought, given, we have basically a year's reserve in any of our reservoirs. Obviously the fact that we've been depleting a very difficult to replenish resource if we continue to draw down on the water table. So I think we all have a great context to think about more specific technologies. Dr. Dozier, thanks for the three that you mentioned, both measurement, forecast, as well as some of the sensor related ideas. I'm going to turn now to our investor, former entrepreneur, Peter Yolles, to talk about his experience as a water entrepreneur. I think it's pretty clear in my earlier conversation with Peter that he sees California doesn't have enough water to maintain our way of life, and many of the kind of established practices must change. He has decades of experience in water conservation. He was director of water resource protection for the Nature Conservancy. He was vice president of Western Water Company and founder and chief policy officer of a company called WaterSmart. Today, he's an impact investor focused on water and climate tech, and as the managing partner of Echo River Capital. I'm gonna ask Peter to share his story from water entrepreneur to investor, and also introduce the entrepreneurs we have participating in this conversation today. Peter?
Great, thanks, Matt. My name is Peter Yolles, and thank you to the Sustainable Change Alliance for hosting the forum and for your members' interest in addressing our water challenges through technology innovation. So really, I think Jeff gave a great background on water. I've been doing water stuff for decades, and as a former entrepreneur myself, I really share the sort of the founder's outlook and the challenges they face. And it really springs from the last 10 years I spent after founding WaterSmart Software, which was one of the first software as a service platforms for water utilities. And I helped grow that business to over 150 water utility customers in 35 states, with the mission of really helping customers save water and find leaks and reduce their water utility bills. And WaterSmart helped millions of customers save billions of gallons of clean drinking water and the related utility charges and carbon emissions that come along from moving, heating, and treating that water. Luckily, after 10 years, WaterSmart was acquired in 2020 with culmination of a long and very fulfilling journey to help address my personal mission of sustainable water management. And what I discovered then and during that journey, and still persists today, is a significant funding gap for early stage water technology companies that are really trying to tackle some of the biggest climate adaptation challenges we face globally. And I say climate adaptation because I think that about 90% of climate effects and climate changes are really water changes through having too much water or not enough water or sea level rise. Really, these are water challenges we all will face. And we also are facing a $2 trillion expected shortfall in funding to provide needed water supply and sanitation globally over the next 20 years. So in both cases, we have significant investment that we have to address, both private capital to support innovation and public capital to support our public utilities and provide clean drinking water and sanitation. So today, as a way to continue my personal journey of sustainable water management, I advise founders, and I am also a personal investor and raising a fund, early stage fund, sharing the lessons I've learned at WaterSmart and really filling this early stage water funding gap. So personally, I'm looking to be a first check or at least be in the first round into these innovative companies that are facing large markets, customer traction, and increasing interest from much larger companies in this space. In fact, last week, we had $1 billion exit when Autodesk acquired the software company Innovise. In fact, we've had about 35 exits out of the water technology space worth over $1 billion in the last 10 years or so. So it's a growing interest, and I think that increasingly a lucrative opportunity for impact investors like those of you on this call. For founders who might be listening, I definitely want to encourage you to apply to one of the many water accelerators and incubators we have around the country. And 3, I wanted to highlight that I look for some of the companies that come out of them are, one is Elemental Accelerator, has a global track and includes water. Applications close there on March 24th, coming up. Another one is the TechStars Sustainability Accelerator, which is, they've partnered with the Nature Conservancy for that. And then the third is Imagine H2O, which actually has 3 different accelerator programs. One is this Classic Accelerator, another is Imagine H2O in Asia, and then another is Urban Water Challenge. And Imagine H2O, just for example, has about 150 alumni companies, and they've raised over $500 million in venture investment for their alumni. So let's move on to our companies today. And I am a fan of both the founders and their companies, but I have neither an investment in or any formal affiliation with either company. So if we're going to follow the urban hydrologic cycle, we'll start with Esther Altura of Drizzlex, which is focused on reducing the consumption and leakage of fresh drinking water in multifamily dwellings or buildings. And I think there are 3 fascinating things to know about Drizzlex. One is the founders are from Israel, the country leading the world in water management, and have made water technology a large export. And Esther and her son are the founders, which is a rarity in the tech world to see a mother-son combination. And third, they developed a really cool technology that I like, which is built for purpose for the retrofit multifamily real estate market, which is cool. A lot of technologies we see is for new build, and I'm excited about retrofitting, which is most of our housing stock. So I'm excited about the possibilities of Drizzlex, and I saw a lot of opportunity in my time at WaterSmart for that. So, and then last, I just like to remind you, Esther, you have about 7 minutes, and I'll keep time and jump in. So take it away, Esther.
Hello, I'm Esther Altura, and I co-founded Drizzlex with my son Ariel. And I would like to share with you a presentation. I know everybody was free format, but I think the presentation will give you some maybe graphic insight into what we're doing. So if you let me, I'll just share my screen right now with you, and I'll do it hopefully very quickly. And here we are. So Drizzlex is focusing on the market, as Peter said, on urban building, and especially multifamily, but not only. And we want to tackle a problem that exists in the multifamily space, and that is that the landlord is responsible for paying the entire water bill for the buildings. There is only one water meter, which is a master meter, and the landlord is paying for it. And why? So if we are looking how most of the multifamily properties are constructed is, if you look on the right side, this is a construction of homes or other places like in Europe, mostly in Israel, where you have the pipes coming in horizontally into an apartment and they're feeding all the water in the apartment. But in the United States, most of the multifamily are constructed with what's called risers, and the pipes actually going vertical. Since you never make any changes in rentals, those buildings are meant for rent, then it's a very convenient and very economic way to build. But there is a drawback, and the drawback is measuring, where in the right side, each apartment has its own water meter, and the tenants or homeowners are paying for their actual water use. And it was definitely researched and provided information that this is the best water conservation. When you pay for your own water use and your action are impacting the bill, then you will conserve water. That was in Israel in 1955, a law was issued that you cannot build a housing unit without a water meter, because that's how you conserve. But that's not the case in United States. And with the riser system, there are many water entries into each one apartment, so there is no way to actually know how much each apartment is using. The only measuring is on a building level. And as such, tenants feel that water is free. Just like air is free, water is free, they can use it in any way. And there are many, many stories. For example, people who are leaving the hot water in the shower to iron their clothes, to press their clothes. And a lot of different kind of things, because when something is free, you are not as careful. So most of the building, basically when a property is constructed with risers, there is a 30% overuse of water and waste. Even if there is a waste in the toilet, tenants do not tell the landlords, and it goes on and on. So we came up with a solution. We said, what are we gonna do with all those properties, as Peter said, that are built already that way and there is no way to change them? So we're ignoring the pipes, vertical or horizontal doesn't make a difference, because we measure water. We developed sensors, small sensors, okay, that we put in each and every water usage in the house, any appliance. So if you look at this apartment, we will install micrometers in the sink, in the toilet, in the tub, everywhere. And we collect data. Based on this data, we know we can sub-meter. We know how much each person is using or each apartment is using. But it's even more than that. If you look at that, our system, instead of focusing on physical water meters, even smart water meter outside, we bring it in, we're collecting the data, and then this dashboard represents, it's 20-unit building. Each line represents an apartment. Each line is actually the sub-metering of the apartment. We know exactly how much they're using. But more so, since we are collecting such detailed data, we give the users of the data an app, and he can see exactly how much water he's using and where he's using. And we empower the tenant or the homeowner or anybody who's using it to conserve water, because you know that your showers are longer, you can compare it to the others, and you have a powerful tool. Eventually, we are not there yet. Eventually, we are gonna also be able to shut off from far each and every appliance. So we're basically turning your home into a smart home for water, which doesn't exist today. So very easy to install. It's a plain plug and play. The battery, we have a patent pending on it. It's lasting 10 years. So the whole micrometer was designed for apartment living. It is very affordable for the landlord who has to spend the money on it. The ROI is very quick. It's tamper-free, and it will last forever. So us as a company, we are going to have recurring income of 10 years of the SaaS that is being paid. We are two founders. We got many prizes here, so that you see on the right side, but we are two founders. And as Peter said, we are very unusual. In general, it's unusual. I'm in a male-dominated area, and I'm a woman, and I'm doing it with my son, and I'm from Israel. So there are a lot of different things that in usual, Ariel is probably one of the world's most experts in IoT and LoRa. We are using LoRa for communication between our micrometer and the cloud. And I have many years of experience in software development, project management, and investment in multifamily. I know this space very well. Market is huge. There are about 80 million housing units that do not have their water meter, and they do not conserve water, and they can install our system and start conserving water. There are many water meters out there, smart water meters. You probably heard AMI, AMR, but all of them are good for, if you remember our first chart of one-to-one or one-to-many, they are very good for one-to-one. When you have 1 meter for one apartment, they can be terrific. But when you have 1 meter to many apartments, you still don't know how much each one is using. You still don't know where the leaks actually occur. Drizzlex is the only solution for this demand right now, this unmet need that needs to be filled. And if you think about it, everything in the world is so connected, yet the water in a multifamily property is a total black hole, and we shine light into this hole. And our business model is made out of 3. We are collecting SaaS from each apartment over the many years. We are gonna bill also the tenants based on that. We have the one-time shot of installing, and we have data. We have an enormous amount of data, and just as of recent, we sold our data to a big Fortune 500 for a very nice amount, and we don't have so much data yet because we are very new. So we are gonna have many, many millions and trillions of records of people usage of data, and this is going to be something that gonna be very valuable. Nobody has it right now. And we are right now online with, we have orders, we have customers in Los Angeles, in Boston, in New York, in Florida. We are working now, we are in early commercialization. We have early adapters who like our system and trying it and getting phenomenal stuff. We have information about leaks that last for a whole day, 3,000 gallons a day. And nobody ever knew about it. And we know, we call the landlord and it stopped right away. So we discover showers of 2 hours, 175 gallons. We discover all kinds of things that just nobody knows. And the system works very well, 24/7. And we're collecting all this data and helping everybody out there. So our goal is in 5 years to get into 1 million. Out of the 80 million, we'll get into 1 million, and we have a huge business here that keep coming, the income keep coming. It's a very strong SaaS business based on the sensors that we developed. Our sensors are state of the art, very reliable. We have a system that can provide a lot of benefit for the environment, a lot of benefits for the property owner who can cut his expenses, and his NOI becomes so much better, and his value of the property is so much better than it was used to be before. And in addition to all of it, we're saving water to the environment.
Thank you, Esther. Amazing. Thanks for running through a huge amount of material very quickly, and it's really impressive technology. I think you found an amazing niche that we really need to help reduce water demand in our urban areas and become more resilient. Where the water goes is our next speaker, Robert Lee, who is the founder and CEO of Subterra. Robert also comes from an arid country, Australia. What's so surprising about Robert's journey is his dedication to his craft of solving wastewater leakage challenges, which is a multi-billion-dollar market and one that we're sorely in need of new innovation. One of the challenging aspects about water is that it is often sight unseen, moving through pipes, something that we don't often think about. But Robert's technology is about to change all that by empowering sewer agencies with the ability to see inside their wastewater pipes to identify where and when to fix these costly and wasteful leakage spots. So Robert, I'll chime in at 7 minutes if you haven't finished, and we'll have a Q&A after that, facilitated by Matthew. So take it away, Robert.
Okay, great. Thank you, Peter. And I'll share my screen also We're a very visual-based company. So So while that loads up, hi everyone, my name is Robert Lee. I'm the CEO and founder of Subterra AI. I come from Australia, but now in the US. And hopefully by the end of this presentation, I'll have you thinking about sewer infrastructure and how it impacts our already stressed water systems, not just in California, but across the globe. Before I jump into the company, just a little bit about myself and how I ended up in sewer pipes. I've got over 14 years industry experience. I have a degree in geoscience, and I've worked in roles as a geologist, geophysicist, and a photogrammetrist, where I became a specialist in underground 3D mapping. So essentially, I can turn an underground environment into a 3D reconstruction that gives us a very objective view. I developed many underground mapping systems and deployed them in underground coal mines, train tunnels, stormwater pipes, and more recently, sewer pipes. And it saw me walk through miles and miles of raw sewerage. And that's where I came up with Subterra AI, a more scalable solution for the world. So why does the water industry need Subterra AI? Well, just looking at the US alone, the wastewater infrastructure is reaching its end of life. It's lasted 50 to 100 years. And the American Society of Civil Engineers rates it at a very poor way, a D+. And there's over 1 million miles of sewer pipes that run throughout America. And 90% of that network goes uninspected each year. And I talk to many clients that have sewers that they've never inspected at all. So they really don't know the condition of these sewer pipes. And what we're seeing is that there's a growing gap of the funding that's needed to repair and replace these sewer pipes. And what happens with broken sewers? Well, obviously that sewage has to go somewhere, and it enters into waterways, making millions of people throughout the US sick, and it's growing. So we're in an era now of not when is it going to fail, it's more about where is it going to fail. And to try and figure that out, you have to actually get into the sewer pipe to really work out where you should be spending your limited funding on the repairs and replacement of sewer pipes. So why aren't they inspecting more? Well, we've got to look at the current methods and technologies in place today. And I should just note, I took this picture standing waist deep in raw sewerage. It's not a very pleasant place to be. These methodologies are dangerous and just totally impractical. You look at the technologies, they're very inefficient and they're outdated. Some of this technology it was developed in the 80s and 90s, still utilizing pan and tilt CCTV cameras. And they come at a price. We see our competitors creating larger, more expensive systems when they should be making small, cost-effective solutions. So what does this have to do with water? Well, it's talking about broken pipes, and you probably think sewage leaking out of these small cracks. What the problem is when it rains, it actually enters into the sewer. It overflows these sewage pipes and it has to go somewhere. And this is called inflow and infiltration. With this overload of these sewer pipes, if it makes it downstream, they have to treat this excess water, which costs money. Otherwise, it backs up into people's homes. And one of our clients spends over $14 million each year just in litigations alone on the cleanup bills of these sewer basement backups. More impactful, enters into our river systems, our drinking water reservoirs and our oceans as sewer overflows. And you can even get onto the Water Board website and see where they are around Santa Barbara. And and you can see it on a daily basis. And this impacts not only tourism and shellfish farms, but also manufacturing, agriculture, and other industries. And also it's making a lot of people sick. So at Subterra, we're automating the inspection process and building the digital twins of this underground infrastructure to understand it a lot better. We're utilizing consumer technology, the gig economy, and AI. So at the core of our solution is our centralized cloud platform that allows our clients to upload all these data streams. We manage the data, process, and analyze it for them. We're making the platform data agnostic, as we're seeing a flood of IoT sensors and monitoring systems for smart cities. At the moment, we're currently focused on video inspections, but we're making data agnostic to take in acoustic, sonar, and other sensing technologies. But one that I'd like to highlight is consumer technology, GoPros and alike. And what we're able to do is reduce the cost of inspections. We've created our own inspection devices, GoPro-enabled devices, creating somewhat like a Google Street View for underground for a fraction of the cost. And we're able to inspect these infrastructure at 20 times more than our competitors. What we can do with that data is we can transform it using our intellectual property platform and turn a video stream into a digital twin or a 3D point cloud that we can georeference. When we georeference something, then we can understand it in a geospatial aspect. We can tag, measure, and compare over time. Throughout this whole process, we're embedding computer vision and AI to automate a lot of the mundane and repetitive tasks in identification and mapping out trends on a more larger basis. We're building a marketplace into our platform to utilize the gig economy. There's over 30,000 certified sewer inspectors in the US alone, and they're going to help us train and scale our machine learning algorithms to give our clients more cost-effective, efficient, and consistent results. So just to give you an idea of our traction, we are a bootstrap company. In 2019, we're Australian and we're deploying our minimal viable products over several paid pilots. Last year, I transitioned the company from Australia to the US, and we won 3 large contracts with an initial product market fit. One of those contracts was worth over $350,000 over 3 years, and we saw a 94% growth rate. This year, we've placed ourselves in a good position to raise our seed round. This will help us deploy our version 1 of our platform and scale across the US, if not the world. We have demand from all over North America, Southeast Asia, Europe, and the Middle East. Just look at the US market alone. There's over 15,000 or close to 15,000 treatment works, essentially sewer networks, that are managing over 1 million miles of sewers. They're spending over $5 billion each year just on sewer inspections alone. So in 3 years, we want to have 600 subscription licenses. We want to inspect over 1% of that network, which will generate a $49 million revenue. To do this, I've put together an entrepreneurial and very expert team, and we're looking to raise our seed round to build on top of this team, not only in software engineers, but our sales team to actually scale this solution across the US and the world. So that concludes my presentation. I hope you enjoyed it, and I hope we've got you thinking about sewer infrastructure and how it impacts our water reservoirs. Thank you very much.
Amazing, Robert. Thank you so much for that presentation. I think we've seen 2 amazing companies that are addressing both the drinking water challenge and the sewage challenge. And if we can reduce and improve efficiency, I think we can also leave more water in our natural environment as well, which would be a great goal in the future. So back to you, Matt.
Oh, thank you so much. I think it's one of the most remarkable things when you have experts like Esther and Robert focused on, solving very specific problems, that you understand the context around all of these other problems. So the infrastructure for how our buildings in the US, our apartment buildings in the US were built. And, Robert, just, how inflows, actually water's coming into the systems versus leaks, actually exacerbate the problems that you're trying to solve. I would kind of ask both of you, just out of general curiosity, you're coming to the US market from abroad. What are some of the unique challenges you've faced in trying to bring to this market solutions that evolved from overseas? Maybe Esther, you could speak to that.
Yes, actually, I'm a dual citizenship. I lived many years in the United States, and that's where I was aware of the problem in the United States. I came from Israel knowing that every drop counts. And when I was in the United States, and especially when I owned some multifamily properties there, I saw that the attitude toward water usage is just totally different. So I took my background as an Israeli because my technology is, it can be used in Israel, but it's not so needed as in the United States. I'm familiar with the United States market. I've been there, so to me, and I have a very large network of people who do have multifamily. So to me, it was a very natural way, and I found myself as an ambassador of the water conservation. And as such, I started the company and thought that I can help people reduce water. And first in multifamily, because they just don't have any answer. And then also to places that do have some answer, but I can improve the answer. So for me, it wasn't a major challenge.
Excellent, excellent. Robert, I'm curious how you, I mean, kind of an odd question, but how do you find our sewers compare?
They're very similar, to tell you the truth. So all through the Western world, urbanizations really increased around World War I and World War II. And then you saw the introduction of larger sewer systems to support that urbanization. So I'm seeing not only in Australia, the US, but also the western part of the Western world of Europe is that they have very similar sewers, very similar problems. The differences are the government, the buying process. And you've asked the question here, what are some of the challenges? And I'm finding how bureaucratic and having to navigate the differences between state and even going down to counties within a state. In Australia, we're luckily all very similar. It's a very similar buying process, but here there's 50 states and I'm going to have to work out 50 ways of selling essentially. So that's where we look to channel partners to scale our solution. Instead of selling direct to municipalities, which we're doing right now, just to build credibility and product market fit, is then selling to engineering firms that have already gone through that procurement.
Excellent, excellent. Well, and clearly you have a plan for that, as you shared your use of proceeds model for ramping up the team around sales. Esther, I'll kind of double back to you on a question about insurance and the multifamily market. We talk a little bit about carrots and sticks, what incentives, what disincentives or fines, penalties, restrictions. Do you find the insurance companies can play a role here? In obviously there's potential for lack of damage or waste or whatnot. How do they play into your model?
Okay, insurance, water claims are the second largest insurance claims after fire. So insurance company has a big incentive to use some kind of mechanism to stop leaks and water damage. They have been trying to work with the smart water meters that exist today. We talked mostly to insurance that work with single family homes. And the saying people are not motivated enough, even if they reduce cost or they give them the tools themselves or the water meters themselves, they won't change the batteries, they won't maintain them properly. So they would give them incentives, but they won't reap the benefit as much. And we have been talking to them, and we will continue to talk to them, because with our system, since it's 10-year battery and you install it and you forget about it, that can really help the insurance company. And with our future ability, we don't have it yet, to close water from far away, a single source of water. So if you left for the office and there is a flood there, the system can, with your help, or even automatically closes water. And we know that in water damage, it takes 10 minutes and it's over. So those few minutes are very critical, and our system will be able to do it. So we are not so advanced with insurance companies. As Robert said, we need to prove ourselves, and we are proving ourselves in the multifamily, because that's working with property management and with owner who has the real critical need right now. I need to be able to see how much water, where my leaks are, and roll the billing to the tenant. That's the biggest issue. Once we get through it in a certain way, insurance company will come next. But they definitely will play a very big role in incentive and in encouraging people to conserve water and to prevent leaks. That's the main thing with insurance companies.
Well, I kind of maybe bring this back to Peter for some context. I think one of the challenges every investment has, especially if you're getting into municipalities or large systems, community systems. There was a comment earlier in the chat about kind of this tragedy of the commons, where it's difficult to get individuals to act responsibly if they don't know the consequence of their actions. But I might kind of bring that to a broader set of questions around kind of the economic buyer, who's involved in these transactions, and what it takes, maybe in your personal experiences having run one of these companies, but what it takes to get municipalities, individual property owners, consumers, the local community. How do you generally kind of advise startups on that and have them think through the complexity of some of these sales or some of these businesses?
Yeah, this is a really good question. There are different answers for both of these businesses. Esther and Drizzlex obviously are selling into the property owners, and there is a huge incentive if they can provide a very fast return on investment, as Esther is showing, of a 12-month payback period. That's very attractive to that customer type. And in addition, the RUBS, or ratio utility billing systems, have really taken off. The ability for building owners to pass on the cost of water to their tenants is a huge driver for them. And this is providing a new way for them to have a very much more precise way of passing those costs on. So from an economic decision, which of course building owners are driven by that primarily, I think Drizzlex is very well positioned to capitalize on the interest in saving costs at the building owners. For Subterra AI, which is selling mostly into the municipal market, I think that Robert, as he describes, I think is onto the right pathway, which is to sell through intermediaries and channel partners who already have trusted advisory relationships with the utilities themselves. So at WaterSmart, which I founded, we did mostly direct selling for the first 5 years, which was slow. And then we added the channel partnership channel onto that, and we doubled sales within the next 12 months in terms of the numbers of utilities. So why reinvent the wheel? Why go and try to establish these trusted relationships with basically a slow sales cycle entity like a municipality, when there are existing regional suppliers or engineering firms that have those channel relationships already? So I think he's got the right pathway. And the good thing about municipalities is they might be slightly slower than enterprises to buy, but they stay around for a long time. So the customer acquisition cost to lifetime value ratio is extremely attractive for municipalities. And it's actually a much better market than many people believe.
Well, that's helpful. I think it's as a novice investor in the category, looking at the category, it's hard to even kind of conceive of what the opportunity is. But using channel partners and working within the system as it's kind of developed seems to make a lot of sense to me. I bring it back to Jeff Dozier, if he's still got some time to kind of talk a little bit about. We looked at infrastructure. On the apartment side, kind of residential, where we're consuming water. We're looking at the sewer infrastructure. You commented a bit, Jeff, about the reservoir infrastructure and how we're able to actually capture some of that, whether it's rain or snow runoff in that system. Any color you can add to kind of the state? Robert had a nice graphic there that showed that we're maybe not having the best grades for our infrastructure systems. Is our larger scale reservoir systems in such a bad shape as well? Do we have much more work to do there?
Well, I think as Robert said, many of these systems were designed 50 to 100 years ago, or built 50 to 100 years ago with a 50 to 100 year design lifetime. And so that is also the case in the reservoir system. That we almost had a pretty catastrophic failure with the Oroville Dam in 2017. The general state of infrastructure in the U.S. is lamentable, in that there needs to be a lot of investment in improving the infrastructure. The part of the infrastructure that really hasn't been developed very well is the groundwater recharge infrastructure. And there are some interesting things about that. When we speak a lot about efficiency in irrigation, and certainly in Israel, they're made huge advancements in that. If you have a lot of water, which you have in some years, then flood irrigation is a good idea, because it helps recharge the groundwater. And so part of the issue in trying to manage the groundwater better is to improve the processes and the infrastructure needed for recharge.
Interesting. Yeah, there's a lot of opportunity. I was just suspecting to invest both at the municipal and government level. Obviously, we have to do more as a society to take care of our infrastructure. But I hope we can explore in our follow-on discussion or in another session later on just what some of those opportunities might be. I wanted to take this time, since we're at the hour, to thank Peter, Esther, Robert, and Jeff for joining us for the conversation. Invite those of you who want to stick around for the next 30 minutes to drop off of this call, where we'll have a private session where we can chat and connect directly. If you do have the time, there should be a link in your inbox to join the conversation there. And again, thank you to Sustainable Change Alliance for organizing impact investing in our community and educating the world on how to do things better, more sustainably. So thank you, and thanks again. We'll be seeing you shortly in the after-hour chat.